Now say for example we are given this question. We are given a set A which has elements 1, 2, 3, 4, 5, 6 and another set B which has these elements 2, 3, 5, 7 and 10. Now a relation is defined from A to B, x or y, such that x plus y is equal to 7. So a relation would be considered between these two elements of these two sets when the sum of these two elements is equal to 7, when x plus y is equal to 7. So whenever x plus y lands us in 7, so then we know that there is a connection between the elements of these two sets. So now let's just try to find these two relations, the relation which is there. So over here the elements are 4, 5 and 6, and over here this is 2, 3, 5, 7 and 10. So we can see that x plus y is equal to 7. So 1 plus 2 is not 7, 1 plus 3, 1 plus 5, 1 plus 7 and so on. In no case we are able to attach this 1 with any other number in this set so that it becomes equal to 7. So 1 is not connected with any element. Now comes 2. For that it is connected because 2 plus 5 is 7. Similarly, does not actually ends up in 7. So 3 is also rejected. Now comes this 4. So for this 4 we can see that plus 3 is 7. For this 5 plus 2 is 7. So these are the elements of this set A which are connected with these elements of set B. Now we know that this complete set is the codomain, as we have just heard. Now domain is what? Domain is those elements of set A which have a connection with elements of set B. So in this case, now we would be able to understand, we would be able to digest this thought that this example, the relation would be elements 2, 4 and 5. Only this 2, 4 and 5 would be in. Why? Because are connected with elements of set B. So this is the domain of this relation. And before me telling you, actually answer it by yourself. Now you know the term. So we can see in this example, range is only these three elements, 2, 3 and 5. Elements in the codomain which have a connection with elements in the set A. So in this case, the range would be only these three elements, 2, 3 and 5. So this is the domain of this given relation and this is the range of this given relation. And codomain is what? This complete set B. So this is the basic complete logic that as to what does a relation means. Because when we just start with functions which we would be doing in today's class itself, we should be first knowing that what is the meaning of a relation is actually. Because the relation is the base from which function starts. Now just let's have a look at one more name and then we'll just start with functions. So now what we are going to discuss is actually something very basic but a new name for you for the first time. But after looking at it, you would be able to clearly identify and understand that what I'm going to talk about. So the first name is 1, 1. I'll just name it 1, 2 and 3. So the first name is 1, 1. So it's a type of relation as the name actually, as the heading suggests. So a 1, 1 relation is a relation in which I'll just represent through the basic set which we have just done, when one element of set A is connected with just one element of B, which means that in a way just one wire is connected. Like one element here is connected to just one element here. One element here is connected to one element here. One here to one here. So this is a 1, 1 relation. Now I'll actually first name this. I'll name this one as 2. Now this one is a many one relation. Many one, as the name actually in itself suggests, that a many-one relation is a relation in which many elements of set A are connected with one element of set B. So it would be something of this type. Many elements of set A are connected with one element of set B. Many elements here, many different elements here are connected with just one element over here. How this, it could totally depend upon the relation which has been given to us, but the basic example is this, that many elements of set A are connected with just one element of set B, for example over here. So this would be the kind of format that would occur in the case of a many-one relation. So I'll just create some examples so that it becomes easy for you to understand. One we have already seen, the example which we have done. We have actually seen one examples. For example, over here, just to make you understand, I'm creating one example. Let's say, for example, I take this set A as -1, 1, -2, 2, and this set B 1, 2, 4, 1, 2, 4, and 7. This set A is -1, 1, -2, 2, and the set B is this. And x or y, let's say it is given as y is equal to x square. Y is equal to x square. So now if I just create this connection, can we see that A has -1, 1, -2, 2, B has 1, 2, 4 and 7. So through this connection, y is equal to x square. Y is the square of x. So can we see that the square of -1 is 1, and the square of 1 also is 1. So these two elements are connected with this one, and -2 and 2 both are connected with this 4. So many elements of set A are connected with one element of set B. This is the example of a many-one relation. So you will face it in many questions, but the thought is to actually just make you understand this logic on a subtle level, that what does a many-one relation or a one-one relation means. So this is not a one-one relation, this is a many-one relation. Why? Because many elements are connected to just one element over here. This is a many-one relation. So I'm just rubbing it now. Let's say, after this, now we are going to talk about the third name, that is a one-many relation, which now the name actually in itself suggests that one element of set A is connected to many elements of set B. One element of set A is connected with many elements of set B. This is a one-many relation. One element here is connected with many elements here. This is the situation. So I'll just create one more example for this. Let's say, again, now let's say A is 1, 2, 4, 7, 8, and let's say B is -1, 1, -2, 2. And now our relation x or y is given to us, where y square is equal to x. Now the square of y is equal to x. So if I just fill this, if I just draw this one now, if I just draw this relation now according to this logic, can we see that over here are 1, 2, 4, 7 and 8, and in this one there is -1, 1, -2 and 2. Now y square is equal to x. So -1 square is 1, 1 square also is 1. So can we see that now this -1 and 1 over here, they are both connected to this 1, and similarly these -2 and 2, they are both connected to this 4, because -2 square also is 4, y square is equal to x, and over here y square is also equal to x. So this is the situation. So can we see through this flow that this is a one-many relation? One element here is connected to many elements over there. I just created these two examples, but there could be so many more. So we just need to understand these basic names. Why? Because now actually this opens all these names together which we have done now actually opens the gate for functions. So now we'll just dive into functions to understand that how and why we have done whatever we have done till this moment in relations first. Now we can just jump into functions. We should be knowing these terms very well, that what is a relation, what are the domain, range and codomain of a relation, and then these names: one-many relation, many-one relation, and the one-one relation. Now just let's have a look at what does a function means. So